Hola, soy Leo Messi y este es mi video. Espero que les guste.
I belong. Everyone could break my heart, but I try my best to not fall apart.
First of all, go ahead and rotate this by 90 degrees. It's going to be 1, 2, 3, 4, 5, and 6. And then you're going to have an OH at the 5 prime there. So this particular group right there at number 5, at chiral center 5, and the carbonyl at number 2, they are going to be the one that are going to be attacking one another to make a, in this case, a 5-membered ring, so that it makes a furanose ring. And then if I try to orient those, in a 5-membered ring, so this is going to be 2, 3, 4, 5, and 6 right there. So at the 2, you're going to have the carbonyl, obviously, and then this CH2OH on the top is still there. So let me move this back a little bit. And then on number 3, you can clearly see the OH is pointed down. So you want to have that pointed down. On number 4, the OH is pointed up. So now on number 5, you can clearly see how I have this OH pointed up, the H is pointed down, and then what I really did, I placed the CH2OH there. So that's going to be your number 6. But remember, it's going to be this oxygen atom at the 5 prime and this carbon that's going to be attacking one another. So what I really got to do is just got to rotate this. So when I rotate this, I'm going to be making this coming down here, and in that case this is going to come down here, and this hydrogen is going to move up. So when I do this all rotation, so some of these positions are going to change so that you have this OH properly oriented in order to attack the carbonyl of this ketone. And then you're going to have the CH2OH on here and the H on here. So now what you can have is this OH is going to be attacking right there, and this is going to come out. And when this comes out, it's going to have a chance of making this OH either going to the down or going to the top. So when I make a 5-membered ring now, so your oxygen is going to be at the 5th position. Once you made the 5-membered ring, go ahead and put down all your hydroxyl group and the CH2OH group there. So let's call on this carbon atom here, we're going to have the H going up, OH coming down, and this next carbon atom, the OH is going up, H is coming down. On this next carbon atom, you got the CH2OH going down and the H coming up here. And on this anomeric carbon, and this particular anomeric carbon is going to be called in the number 2, and that's because of the reference that goes back to the open chain. So in the open chain, your hydroxyl carbon is going to be number 1, and as a result that still stays the same. So you could have this CH2OH group either coming to the top or to the bottom. So let me just draw out, in this particular case, going to the top, so CH2OH, and this is going to be called 1, 2, 3, 4, 5, and then this is going to be 6, obviously, even though it's a 5-membered ring, and you would think, okay, this should have been called 1, but just to keep the reference to be the same with respect to the open chain fructose here, your anomeric carbon is going to be the number 2 here. So this is your anomeric carbon. So that's the difference between the aldohexose and these ketohexose when you make a 6-membered ring versus a 5-membered ring there. So you're going to have an OH there, and that's pretty much it. So like I said, you could make a the second anomeric anomer as well. So when I make the second anomer, it's just going to be pointed down. So I'm just going to draw that down here. So the difference is going to be the position of the OH is going to be pointed up now, and the CH2 OH is going to be down here, and this should have been CH2OH here. And in order to identify which one is alpha and beta, so let's just go back and focus on the position of the hydroxy group on the anomeric carbon with respect to the CH2OH group on the 6th carbon. So if I change the color here, I can clearly see this OH is pointed down here, and then the CH2OH is also pointed down. And since they are cis to one another, this particular one is going to be a beta. So this is going to be beta L fructose. And then the second one, since you have the OH and this CH2OH, they are trans to one another, where one is pointed down and the other one is pointed up. This is going to be your alpha L fructose. Okay, so then if this was an L fructose, remember from the Haworth projections, you can tell based on the position of this particular group CH2OH, if it's pointed down, that tells you it's going to be an L form, and if this was pointed up, it would have been in a D form. So this is how you're going to be drawing these conversion structures from linear to the cyclic. If you have any questions, feel free to leave any comments in the section below.